Hi scholars, today we're going to talk about linear relationships and how they show up on the SAT. So when you hear the word linear, likely you think about a line, right? So we can imagine here's our XY plane, right? Our Cartesian plane, and we could draw a line, right? Could look something like this, right? And you might also have in your mind this equation, right? Which is y equals mx plus b. And this is the equation of a line. It's one way of writing the equation of a line. You notice, of course, it has an m, which we call the slope. And the slope of a line basically represents for every time I go over x by 1 unit, right? So I could say as x goes over by 1 unit, the slope is saying how much does y go over, right? Does it go up? If it goes up, the slope is positive. If it goes down, right, in a line that goes this way, right, for example, the slope would be negative. And then we have our plus b, and the plus b is really, the b is the y-intercept. If b is positive, right, in this case b is positive, right, because you see you have the point 0b is right there, that's the y-intercept of this line. Then it would be above the x-axis, and if b is negative, of course, it would be below the x-axis. So we can change the slope, we can change the y-intercept, and the nice thing about this sort of picture is that we are able to interpret these values of m and b in a context, right? So if it's not just x and y, but maybe it's number of years and height or something else, right? We can actually interpret these two values. Now, another idea, another image, or another, equation that you might have in your mind is the definition of slope, right? How did we calculate slope? And we could say it's like a change in y over a change in x, which really does like come immediately from this definition, this sort of pictorial definition that we have here. How does y change as x changes, right? So how is this value changing as x is changing? And you might also remember something that looked sort of an uglier version of this, like y2 minus y1. And I'm sure you guys remember calculating this thing. Probably around 9th grade or 8th grade or something like that, right? And you have to remember which one is y2, y1. And again, these are just saying that if you have, the idea with this formula is basically that if you have, so here, let's put this in a different color. The idea with this formula for slope is that if you have 2 points, right, any 2 points, that determines what the line is, right? And so if you know the coordinates, right? If you know the coordinates of this point, which is could be x1, y1. If you know the coordinates of this point, x2, y2, right? For example, those are 4 numbers, and with those 4 numbers, you can calculate the slope. And if you can calculate the slope, right? This slope right here is the same, right, as this slope right here. So if you can calculate the slope, you can then say something about how y changes as x changes, or how one value changes as another one does, right, if we're doing it within context. So that's a quick summary of everything that's important about lines. Before we go on to the problems, just a quick reminder, if you are confused with a problem, don't know where to start, first step should be to annotate, right? So underline whatever information matters, make sure you know what you're being asked for, right? This is very important. You want to see if you can summarize it in your own words, just run it through in your brain, or even speak it out loud, right? What is this problem about? What are we really being asked to do? Create a plan. You want to find a solution pathway. What steps are you going to take? Solve it and check. Okay. And so, right, there's a nice sort of summary. Annotate, summarize, plan, solve, and check. Now, you don't have to do that, of course, for all problems, but for some problems it is very helpful, especially when you don't know where to start. And again, there are some heuristic strategies that questions you can ask yourself if you find yourself stumped. And I went over those in the first video, so I'm not going to do it right now. All right, let's take a look at some questions. So when we go through these questions, I encourage you please pause the video, read the question, try to solve it yourself. If you got it, that's great. You can move on, and if not, then you can start the video again, right, and see sort of some of the thinking that goes into it. Okay. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Well, that seems like it could be useful. This is a number, and they're telling us words per minute, so it's a rate of some kind. Donald can currently type 180 words per minute. That's likely important. And believes that with practice, he can increase his speed by 5 words per minute each month. Okay? Which of the following represents the number of words per minute that Donald believes he will be able to type n months from now, right? So what's important right there is that we're looking for the number that thinks that he is able to type m months from now. So we have some information, we underline some important things, we know what we're looking for, right? Well, the question is, does it matter what the requirements to become a court reporter are? Now, in the context of what the question is asking, what we're being asked, that information doesn't really matter, right? What matters is how many can he type now? So he can currently type 180, right? We underline that, so I'm going to write that here, 180. And then he can increase his typing speed by 5 words per minute every month, right? So after 1 month, he can now type 185 words per minute. He increased it by 5, right? After 2 months, he can do 190 words per minute. After 3, 195, and so forth and so on, right? The idea is that after every additional month, which is represented by M, every month, right, gives him an additional 5 words per minute. If he starts with 180, and every additional month, right, 1 month, 2 months, 3 months, he gets an additional 5 words, this right here is our expression. Okay, so the answer looks like is C. C is going to be our answer here. Now, in this question, if we wanted to incorporate 225 words per minute, we could have said, the question could have asked, how many months will it take him before he can become a court reporter? And that would be the question, 180 plus 5M, what he's doing now every month. How long will it take? How many months would it take until we get to 225, right? So then you can sort of solve that equation. I think it ends up being what, 45, 9, about 9 months it'll take him if he keeps increasing his rate of typing at this amount, right? And so just a sort of a final closing thing, we notice that in this question, although this is like sort of a paragraph, you have to read it, you have to think about everything. This whole first piece right here, this whole first sentence is not really used in the problem. And we can identify that this is not that useful only if we're able to identify what the question is asking us to do, right? So even when I was reading through, I said, let's start by underlining this. But when you get to where you find out what you're being asked, you might want to go back and say, oh, actually, I thought this was important, but it's not really important, right? The question is not asking me anything about becoming a court reporter. It's asking me about Donald and his rate of typing. Okay, let's go to another question. The normal systolic blood pressure, P, in millimeters of mercury for an adult male X years old can be modeled by the equation P equals X plus 220, that quantity over 2. Okay, so clearly we got a nice equation, and it might be useful also to say that I know that P represents normal systolic blood pressure, and X is how many years old, right? Okay, so that's helpful. According to the model, for every increase of 1 year in age, okay, which really is saying, if I wanted to sort of summarize, for every increase of 1 year's age is really saying as X, which is the number of years old, right, increases by 1 unit, right, or 1 year, right, we could even call it, we're talking X is years, right, so by 1 year, okay, so that's the interpretation of every increase of 1 year in age, right, okay. By how many millimeters, so for every increase of X 1 year, right, by how many millimeters of mercury will the normal systolic blood pressure for adult males increase? So it is a mouthful. These sentences are long, they're complicated, there are many commas in them, or whatever, right? But basically this question is asking, right, if we wanted to sort of put the box around, right, whatever, what the question is asking, right, how does P change? Right, P is the normal systolic blood pressure, right? Remember, we found that out here. So the question is asking, how does P change as X increases by 1 year? Okay, so that is our question. Okay. So really, the question is asking, what is the slope of this equation, right? Because that's exactly the definition of slope. Now I think, okay, I know that slope, we can write it as like y equals mx plus b, right? And so basically we're looking for the value of the slope. And here I have an equation, which is p, and so p plays the role of y here, right? It's just a different letter. P equals, and I have this thing that says x plus 220 over 2. And I'm thinking, this doesn't really look like this. It's not in the same form, right? We're sort of dividing by 2 here. I can't really see immediately where the slope is. Well, there's a way around this, okay? So the way around this is, let's actually, since I'm dividing two terms, right, in the numerator by 1 in the denominator, I can divide separately, right? I can divide x by 2, and I can divide 220 by 2. So let's do 220 by 2. 220 by 2 is 110. So I'm going to write just below here, I'm going to write p equals, and I'm just going to put plus 110, right? So we just did this division. And now I want to do x divided by 2, which I could write as x over 2. I could also write that as 1/2 of x, right? That's what x over 2 is. If I write it that way, I see immediately, sure, what the slope is, right? So if I want to answer my question, how many millimeters of mercury will it increase, right, for every 1 year of age? The answer is 1/2. It'll increase 1/2 millimeter, or so you could write 1/2 millimeter, or you could write 0.5, right? Same thing, millimeter. So this is your answer for this question. And so just sort of as a step back before we go on to our last question, right? What information or how did we help, how do we solve this problem? And what we did is we said, I'm given an equation that's in a form, right? The expression over here is put together in a form that is not the form that I'm used to, which is a y equals mx plus b. So what's my goal? My goal is going to be to let me see if I can change this so it looks like y equals mx plus b, because then I know my answer, right? There it is, 1/2. Okay, let's do one more problem. The mesosphere is the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above Earth's surface. At a distance of 50 kilometers from the Earth's surface, the temperature in the mesosphere is -5 degrees Celsius, and at a distance of 80 kilometers from the Earth's surface, the temperature in the mesosphere is -80 degrees Celsius. Okay, so that's sort of a mouthful, so let's actually take a look at what this means, sort of an idea to summarize it, right? Here we are on Earth, here we are, sitting on Earth's surface, that's fine. There are two places above us that the question is asking us to consider. One is 50 kilometers above Earth's surface. So let's take a look. So somewhere, right, 50 kilometers above is one spot, okay, that we're being asked to consider. And at that point, the temperature is -5, okay, Celsius, fine. And then there's another spot, which is maybe up here, right? And this is 80 kilometers, okay? And at this spot, the temperature is -80, right? Okay. So here's our picture. It's one way we can think about it. Of course, this is our Mother Earth. Okay. For every additional 10 kilometers from Earth's surface, so this right here is, of course, going to be relevant to our question, what we're being asked. Okay. For every additional 10 kilometers from Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius, where k is a constant. What is the value of k? Okay, so here's our question. So to paraphrase, they're saying for every additional 10 kilometers from Earth's surface, so here we go. Here we're at 50 kilometers, and it's saying if I go 10 kilometers above to 60, right? The temperature it is certainly going down, right? It's going from -5 to -80. It's because when you increase from the Earth's surface, temperature gets colder and colder. But it's saying for that additional 10 kilometer jump, right? How much is the value of k? Like how many degrees in Celsius, right? Is that decrease worth? So believe it or not, this is actually a slope problem, right? So we know the slope is change in y over change in x. And we can model this situation using these numbers, right? We can say that as we move from 50 to 80, right? So on the bottom, I can do 50 minus 80. As the kilometers change, right? As the kilometers increase above the Earth's surface, how does the temperature change? Well, from 50 to 80, at 50, it was at -5, right? And at 80, it was at -80. So again, we can do our y2 minus y1, x2 minus x1, right? And we can make sure that we are mapping the fact that this -5 and this 50, right? This is one set. It's almost like a coordinate pair here, right? And same thing with our -80 degrees Celsius for 80 kilometers above. And so we can do a little math here if we wanted to. And we get on the top, we're going to get, this looks like 75, I believe. And on the bottom, we're going to get 50 minus 80, looks like a -30. And I could reduce that and get an actual number, but here we're being asked for every additional 10 kilometers, right? So the question isn't how much is it for 30, it's the question is how much is it for every additional 10? Well, I can divide 30 by 10, right? 75 by 3. You can move you can move negative signs up. And so the answer right here, it appears to be, is that -25 is our answer, right? That says the temperature decreases by, but here's a tricky piece, right? Does it decrease by 25 degrees or -25 degrees? No, it decreases by 25 degrees. That's where the decrease comes up with the negative sign right there, right? So by this word decreases by k degrees, it's telling you we've already taken into account that the temperature is getting less, it's getting lower, right? It's moving into a negative direction. And so our answer, if they say, what's the value of k? The answer is actually k equals 25, okay? Because we are decreasing by 25 degrees. That's it. Have a great week.